Assalamu alaikum. Good morning, everyone. Ramadan Kareem. Today we will continue our lesson that we already started yesterday, which is 11.6 segment relationships and circles. Okay, to remind you about the objectives, we will find the lengths of segments formed by lines that intersect circles or all types, and to use the lengths of segments and circles to solve problems. Now, the third idea in this lesson yesterday, if you remember, we talked about two ideas that if the two chords intersect inside the circle, and we took the theorem, which is the chord theorem, product theorem, and also if the two secants intersect outside the circle in the exterior part of the circle, and we took the secant segment product theorem. Today now we will continue the third idea in this lesson, which is about the tangent segment. Tangent segment. A tangent segment is a segment of a tangent with one endpoint on the circle, like AB and AC. AB and AC are tangent segments. Again, the tangents we took in the first lesson, if you remember, the tangent is a line that intersects the circle in exactly one point. So it is a line, not a segment. So the tangent segment, it means that we are taking a part of the tangent. What is that specific part? The part is from the circle, from the intersection point of the circle and the tangent, and any exterior point. Now, AB and AC both are tangents, and both we took the secant tangent or the tangent secant from both of them. Yani the line must be like this, all and like that, but we took only a part. Okay. What is the third theorem in this lesson? It is the secant tangent product theorem. Secant tangent product theorem. If you remember, in the first theorem, we had two parts for each chord. You can go through that theorem and see. In the second theorem, also, we had four parts. One interior, the other is exterior for both two secants. Now, in here, what do we have in the third theorem? We have a secant, so we have interior part, and we have exterior part of the secant segment. And we have a tangent. Now, the tangent has only one exterior part because the tangent will not go inside the circle. It will touch only the circle. Okay, so this one only exterior part. So what do we have to do? If you remember again in the first and in the second theorem, we said that in the first theorem the product of the parts of the chords are equal in both chords, and in the second one the whole secant segment times the exterior part is equal to the whole times the exterior. Okay, now in this theorem, if we multiply the whole secant segment multiplied by the external part BC, it will be equal to the tangent segment squared. It means AC times BC, AC is the whole, times the external, which is BC, is equal to DC times DC. We don't have any other part, so we will multiply it by itself twice. DC times DC, AC times BC is equal to DC squared. An example for this theorem, applying the secant tangent product theorem, find the value of x. Look here, we want to find the x. X here is the tangent segment. Okay, so we will write the theorem. The theorem says that if we multiply the whole LM times the exterior part, it will be equal to the exterior part times the exterior part here for the tangent. It means x squared. So ML all times the exterior part, which is JL, is equal to KL squared. KL times KL, it means KL squared. Okay, now substitute 20 times 5 is equal to x squared. 20 times 5 is 100 equal to x squared. To get x, we can take, or we have to take, the square root for both sides to get x is equal to positive or negative 10. Of course, the negative 10 we can take because this is a length and the length can't be negative. So the value of x must be 10 since it represents a length. Check it out for the same theorem. Find the value of y. Now the y is the interior part of the secant segment. Okay, so we will write the theorem. The theorem says df times de is equal to dg times dg or dg squared. So de is the exterior part 7 times 7 plus y. 7 plus 7 plus y is equal to 10 squared. Now, we can divide both sides. We can move this 7 to the other side by dividing, but this is not a good idea here because this 7 is not a factor for the 10 square. 10 square is 100 and 7 is not a factor of it. So if we move it by dividing, then we will have a fraction. It won't be a good idea. So we did the distributive property, 7 times 7 times 7 times y, which is equal to this. Now move the 49 to the other side by subtraction. Divide by 7 to get y equal to 7 and 2 over 7. Now only this one we want to find. That's all for today. Thanks for watching. Hope you understood everything in this lesson. If you have any doubt, please tell me. Thanks a lot.